Good afternoon, it's Lee Cassidy from Tactile Technology, and we've got Boris on with us today from Diamanti. And what we're going to do is learn a little bit about Boris, but also look about how you can use Elasticsearch and deploy Elasticsearch on Diamanti, and where you can get high performance from less infrastructure, but also make it easier to deploy as well. So let's go over to Boris then. So, good afternoon, Boris. How are you?
Afternoon, doing great. How are you?
Yeah, it'd be good to learn a little bit about yourself. So, can you give us a bit of your background? I'm going to say, I know you're living in Amsterdam at the moment, but that's not where you're from, and you've also spent some time in the US as well, haven't you?
Yeah. Hello everybody. My name is Boris. I am originally from Bulgaria, but I live in the US. And because of the fact that I was born here, I'm able to obviously work on both continents. And as Diamanti is expanding its world footprint, I came out here to support the technical side of our sales expansion.
So, how long
So
were you in the US?
I have lived there for 20 years or so.
That's a
Yeah.
reasonable
So I
amount of
basically
time.
grew up there.
Yeah.
Yeah. More or less grew up there.
So, how long have you been at Demonte?
So I've been with Diamanti for 3 years or so now. In Silicon Valley terms, I'm a veteran. I've seen the company grow from 30 people to now over 100, and seeing the kind of the fast pace that the world of containers and Kubernetes in general has just turned into.
And your role is a very technical one, isn't it? You're a CTO for, is that for EMEA?
Yeah, it's for generally the company. Right now, obviously, I'm based in EMEA, so I'm predominantly focusing on EMEA, but I'm doing we'll call it field CTO work for the company in general, which does involve everything from me being on the command line nonstop, working with engineering, to doing interviews and presentations, and just uh, yeah, in general, supporting the success of the company in whatever way and capacity I can.
Okay, so look, we were going to talk about Elasticsearch because part of the interview we did with Friso last week, we talked about some of the key deployments, and one of them that we discussed with Elasticsearch, but we also talked about Kafka. But I think it was important that we spent a bit more time on Elasticsearch because it is a challenging platform for people to deploy, and it's been used quite widely in especially finance type organizations as well. So it'd be quite useful to do that. So you're gonna got a couple of slides for us, I believe.
Yeah, I was just gonna, throw about 4 or 5 slides to just walk through the story and that we're trying to tell today.
Okay, if you want to load your slides then, and we'll kick off.
That's good.
There we are.
Okay. So, uh, first and foremost, you may have already seen this slide once or twice, but I think it's an important thing to tell. As new technologies come to the market, whether it's containers, whether it was VMs, before, and whatever, it doesn't matter what it is. Everybody goes through the process on the left, almost exclusively, right?
Yeah.
And that process, as much as people want it to be nice and short, and hey, we're going to evaluate this new technology and we're going to put it in production, it never works out that way. Management always wants it to be 3 to 6 months, but in reality, it takes about a year before a new evaluation of a fresh technology such as Kubernetes really becomes a viable production ready platform. So what we do on the surface as a company is try to shorten that and give you an all-in-one package that lets you rack our machines, turn on the lights, and you're ready to run Kubernetes. We handle support, we handle upgrades, we handle everything from the hardware all the way through Kubernetes itself. Thus, hopefully reducing that 3 to 6 months to actually be shorter than even 3 months.
Yeah, because I think that's been a challenge for a lot of organisations that they have to self-support in a lot of places. Whereas with this, you're actually looking after the hardware through all the software layers up to the application, aren't you?
Correct. Yeah. So that frees up full-time employees that before had to be concerned with how am I going to upgrade this new thing that we deployed to production. How am I going to make sure that we don't have any failures during this upgrade? To now be essentially a managed process that you are in charge of, but we give you all the tools to do it seamlessly. Which means that again, your time is freed up with more important work than doing mundane maintenance tasks.
Okay.
Yeah. And this is just a summary of the different components that we kind of bring to the Kubernetes ecosystem. First is kind of the bottom layer of the stack, which is our Diamanti D20 appliances. They integrate GPUs and NVMe hard drives in a box. And obviously, as you add more boxes into your Kubernetes cluster, the more of the storage and GPU power and network that you get access to do interesting things with and solve interesting problems, such as Elastic with.
Okay.
But those are white label machines at the end of the day. We're not in the market to uh, try to compete with Dell and Lenovo and the Intels of the world. So they actually build the boxes for us. So where our contribution, if you will, or secret sauce is the middle layer,
Yeah.
and that's our Diamanti Ultima layer, which is two PCIe cards that get added to those appliances. They give you a much better and much easier kind of integration points of Kubernetes with your existing networking stack and existing kind of storage mentality and usage and what you want to do and how you want to do it.
And this is
And I'm
in
going to,
line with what the cloud providers are doing anyway, isn't it? A lot of them are actually offloading both network and storage away from the compute components.
correct. You might have heard of Amazon's Nitro, which does a similar thing. The problem with Nitro is when you look at the architecture, because of how AWS works, you still have a hypervisor layer that sits in the middle, in between all of your workloads. So even though that they're able to accelerate and offload a lot of the IO, it is not able to get the same type of performance numbers that we're able to push through our cards. But the idea is similar, correct?
Okay.
And then finally, we have our software stack right at the top, which is Diamanti Spectra, that lets you kind of have a single pane of glass view of your workloads, your clusters, obviously integrating with the hardware so it's seamless. And to the end user, they don't need to know that they're running on Diamanti or AWS. All they care about is I want my workload and I need a certain amount of performance, and I want to get it through a seemingly seamless consumable interface. Okay, so I like this slide for the sole reason that it shows you that through the power of open source and specifically through the container native foundations and the certification, that every one of these, let's call them Kubernetes distributions, have to get certified as a CNCF distribution. That means that any workload that runs on Diamanti will be able to run on OpenShift, will be able to run on Tanzu, will be able to run on Rancher, will be able to run on any distribution out there that is CNCF certified. And more or less everybody on the surface provides the same type of features. What kind of becomes more problematic is when you want to integrate with everything else that exists in your um, catalog, right? All the different other applications, different other things that want to consume resources that maybe live in Kubernetes. And this is where our hardware platform really shines by giving you a bunch of features that are not available out of the box in Kubernetes through our Ultima layer, such as the ability to do QoS, do quality of service on the network and on your storage side, so you can dedicate IOPS and network bandwidth to workloads, thus eliminating the problem of multi-tenancy noisy neighbor, where somebody on the cluster is just consuming the entirety of the cluster, or is getting DDoSed or whatever the reason may be. Then we give you a lot of storage, enterprise storage level um, features, such as snapshotting of data, backups, synchronous and asynchronous. And some of this you will see today when we're talking about Elastic, and hopefully I'll be able to show you the components that the data protection bits that we have become really, really important. Stretch clustering, not a lot of people think about this, but Kubernetes doesn't exactly come with stretch clustering built in or guarantees around performance, even when you do manage to stretch it. And now our ability to stretch the cluster gives you the geographical distribution of your cluster. So you can have parts of it in one geolocation, and for disaster recovery have the other part in the other geolocation. Again, this becomes more of a kind of pain point as larger enterprises start deploying some of these technologies.
I would assume as well you could use that to provide different sites for data to be stored, depending on the organization's requirement around data protection.
Correct. Yes. So now you can think of, in Europe, we obviously have the GRDP, which restricts where and what and how data can go, whereas the US has its own set of restrictions and rules. So now you can have a seamless cluster and maintain integrity of data for the location that the data is living in. And then some of the things that we're going to actually use today as well is our ability to do encryption from data at rest encryption out of the box. We're utilizing the ability for you to essentially turn on encryption on the persistent volume claim level, which means that you can start with a workload and realize that, hey, this workload is now going to have to go in production for whatever emergency reason, whatever the reason may be. I need my data to be more secure than what it would be otherwise, and you just kind of can flip a button on and get that encryption automatically done for you.
And I bet that's quite
And
important, especially with finance-based applications, as people are deploying into containers. That protection of that data is quite important, isn't it?
yeah, for sure. Especially with Elastic. Elastic is becoming very quickly the brains behind a lot of transactional banking data and kind of the store point, search point for that type of data. And in the US, there's the PCI certification. Obviously, here we have similar certifications when it comes to what banking data can be uh, stored, used, how it can be transmitted. So it definitely helps with those solving those problems. All right. So now we kind of get into the bulk of hopefully what we came to talk about today. This is just a quick overview of real world workloads and them running on Diamanti versus just conventional methods. This is coming from existing clients, and it's not it's not things that I'm just pulling out of thin air and just throwing on a slide. All of these are, again, production level workloads that are running in our clients' data centers today.
So it's giving a
Uh,
realistic impression of what you should achieve with each of those workload types.
Correct. And you will see that a lot of the workloads here are IO intensive, which again makes sense. We do accelerate the IO layer a lot. And the kind of marriage between IO and the next evolution of computing that is containers is important because I would say up until well the birth of my company and then recently Nitro and everything else, containers were a really nice way to develop for stateless applications in the stateless layer. However, the stateful application became a little more stagnant, even though there was mechanisms. The performance wasn't there, the reliability wasn't there, the ability to consume stateful workloads was, what I would call wonky. So hopefully this just kind of shows that hey, you can run important, big, known applications on Kubernetes and have a ton of TCO savings, a ton of IO, a ton of footprint reduction as far as hardware needed to run it. So
Yeah, and so that's been a challenge for a lot of organizations. They could write their application and they could seamlessly move that application around, but they were struggling to get the data, to wherever it needed to be, for those, especially those
uh,
stateful application sets.
yeah, correct. Um, so we're going to just kind of dive into Elastic. As we already said, it is databases are never easy. It doesn't matter whether you're running them in VMs or in just regular bare metal machines. It is never an easy job to optimize databases. And it's even trickier managing databases and upgrading and dealing with that migration paths. And the beautiful thing that Kubernetes has allowed a lot of these providers is to give you um, just easy button essentially by utilizing containers and utilizing Kubernetes standard APIs in order to create um, a much more kind of friendly way to deal with the full life cycle of the application. We already mentioned that with something like Elasticsearch, IO is extremely important, and the more banks and financial industries are using it, the more they are looking to it to get real time data reporting out of it. In order to be able to do real time reporting, you need the right amount of uh, or the right type of hardware sitting underneath it. So
Yeah, and what we've seen in the past is people over provisioning to be able to get to that level of performance, which is, it's going to cost you more money. You're going to be spending maybe 2 or 3 times what you would need to do that.
yeah, that is 100% true. And if you think about it, the larger your footprint is, the more likely there would be problems whenever you go to upgrade from version Elastic 7 to Elastic 8, 9, 10, whatever the next kind of big versions are, which means that you have much more or a larger footprint, but you also have a larger kind of failure target, if you will, as you have to over provision in order to get the performance that you're looking for. So here is and now at this point we're going to kind of get into the technicals of what we're doing and how we're utilizing Diamanti. Here is what I would call a reference architecture Elasticsearch. And this is what we're hopefully going to deploy today live, assuming the demo gods are with us.
Yeah, it's always fun a live demo, isn't it?
For sure. But you can see here that utilizing our Ultima layer, which gives you a direct network control for all containers, we're able to have leg ups in 2 different networks at the same time for our Elastic ingest layer. That means the ingest layer is the only public-facing part of the cluster, which reduces your attack footprint from a security standpoint. You can grow your ingestion layer, and it is again the only point of entry into the cluster. You'll notice that all the other components are living on the private network, which means the outside world doesn't even know they exist, right?
Yeah, so it's less areas to focus on from a security perspective.
Correct. So it kind of makes your setup more secure just from the get-go, without having to uh, start enabling XPack extensions and things like that, just by again greatly reducing the footprint, the public-facing footprint of your cluster. I don't know if people have read this, but there was a huge private VPN companies leaked something like 1.5 terabytes worth of data due to the fact that they had a public-facing Elasticsearch cluster that was just live on the internet. By doing this, you're greatly reducing the chances of that happening, right? And the other kind of things that I want to point out here is the data breakup. And the data breakup is very important from the simple perspective of I want what Elasticsearch refers to as hot data to be running on my fastest and best hardware, my fastest and best hard disks, and I want access to that data to be near real time. And you will see here in the little locks on the storage layer, we are enabling encryption for these volumes, as that data obviously is containing sensitive things. If you're talking about financial industries, you're talking about transactional data, you're talking about credit card numbers, bank numbers, personal information, all sorts of things. So we want to make sure that that data is encrypted at rest. Similarly for warm data, right? That's a little less frequently used data, but it still needs to be protected. It still needs to be easily accessible and visible to the end user. And finally, we have the last bucket of data, which is the cold data. And we fully realize that it does not really make sense to archive data on SSDs, for example, right? Most enterprises at this point in time already have invested heavily in some sort of a storage solution. We are able to integrate with any existing on-prem solution through iSCSI, NFS, and other mechanisms, thus giving you access to that storage pool that's already existing in your
What
company.
about
And you
object
can,
storage? Can you use object-based platforms?
yep, we actually can enable S3 compatibility for our drives, or we can access S3 object storage relatively easily. So if you're already kind of riding the object store train, again, full integration is available, so you're not skipping a beat and trying to scratch your head. How are you going to integrate,
So lots of flexibility
one
on
with
that
the other?
external storage, file, block, and also object.
Correct. Yeah. And I don't have this probably displayed here, but on the master side, uh, from an Elastic perspective, kind of the masters hold a lot of important cluster metadata along with safe searches and other things. So in a case of a failure, the faster your masters recover, the faster you're going to be able to start utilizing your data and you utilizing your cluster again. And what we do here on the master side is we actually enable the Diamanti synchronous replication, which means that the master's data is block for block replicated 3 ways. So to 3 other nodes within the cluster, that could be 3 other geographically spread nodes or 3 other racks in a data center. it's entirely up to you how you want to kind of divvy up the geolocation and whatever the geolocation means uh, for the customer. But and again, I'll point it out when we do it live. The three-way mirrors. So with that set up, and this is, I'm utilizing this from again in a existing customer in production, consuming and processing about 2.5 billion events today, and that's all banking, financial type transactions, and it's about 150 200 gigs of data just streaming in. We were able to kind of slash the indexing delay, which means the data has come in. How long does it take the system to process it by half? Which is huge, right? If you have I don't know, a 50 server cluster that is still struggling with processing the data you have, and then you take two of our nodes and are able to slash the kind of the most important metric by half, you're already winning,
Yeah,
if you
definitely,
will.
definitely.
And it was just kind of more of a technical breakdown of what was done and how it was achieved. But you can see that we went from 16 physical nodes to 2 Diamanti nodes, and we're able to again give them the data boost that they needed. And what it has happened now is um, because of all of this, one, the elastic adoption has grown within the company because they can do more with elastic, and the demand for well, obviously more Diamanti boxes and more elastic licenses has actually grown as they now have the flexibility and the ability to uh, get more clusters up, expand existing clusters, shrink them, do all the things that are much harder when you have just a bunch of servers in a data center.
Yeah, and so shrinking down infrastructure is not just a saving on the infrastructure; it's also saving on licensing if you're actually paying for any licenses as well.
Correct, correct. And most companies have a much more favorable licensing terms when it comes to containers versus say VMs and just regular hardware nodes. So again, the TCO equation becomes much more lucrative when you look in the container world. And I think at this point, I was going to switch out of here and hopefully try to walk through deploying what we showed here live.
I'm looking forward to it, and
So
let's hope the demo gods are looking favourable on us.
yeah, I really do hope that is the case. Okay. So right here, you will see this is our current GUI. We're about to release a new version of our software, which is going to look quite drastically different. But for the moment, this is, I think, good enough for what we're trying to do. So I just want to show that this is a actual live cluster. I do have workloads running on this, so I'm not trying to pull a fast one on anybody. I do have a bunch of different workloads here. None of them are elastic. That is important to, I think, showcase that again, we're going to do this live and deal with the repercussions of doing it live. Um, and the other thing I wanted to point out is I'm actually going to start from scratch. And this brings me back to the CNCF certification that we talked about at the start of this. Because we are a CNCF certified distribution, that means that I can go directly to the Elastic website and they have Kubernetes specific instructions on how to run Elastic and what to do with it. And I'm going to start again from those instructions. I don't have to do anything fancy or Diamanti specific. I'm just copying and pasting things straight into my command line. I'm going to do it from the command line just because it's a little bit quicker to show the resources and things happening. So I'm going to follow the instructions as told on the website and install the Elastic resource into Kubernetes. And we'll see the Elastic operator is now running, which means that at this point I'm free to deploy Elasticsearch architectures and clusters at will.
Okay.
Now, what we showed earlier in our picture is master with some coordinator nodes, a few ingest nodes, and then the different data buckets. So that is exactly what I'm going to be deploying here. Obviously, Elastic gives you a lot of tunable options that you can do here. So, the in-house Elastic expert has access to absolutely every single option that Elastic gives you. Although I am technical and I know enough about Elastic to shoot myself in the foot, I cannot say that that is my day-to-day job. So I spent a lot of time working with an actual Elastic engineer and designing all of this to, at the end of the day, be able to say that, hey, this reference architecture is going to be able to do what we are saying it's going to be able to do.
And in the UK, we've got a saying: you know enough to be dangerous.
Exactly. Yes, I know enough to be dangerous, and I know enough to be able to talk about things intelligently. But if you ask me to do this on a daily basis to earn my living, then we're going to be in trouble.
So this is the YAML file you're setting up for the actual production environment.
Yeah, correct. And what I wanted to point out is the storage class right here. I have, as people are consuming Kubernetes, it is important to point out that not every platform gives you the standard way. And what I mean standard way is standard Kubernetes objects to consume their kind of innovations. What we have done is exactly the opposite. We spent a lot of time and effort, and we've contributed a lot of code back into Kubernetes core to make sure that you can just define a storage class that utilizes Diamanti's innovations. And that is all that an end user, a consumer of the platform has to know or worry about. They don't have to know anything special about Diamanti or anything else. Obviously, the person operating in the cluster has much deeper view and all of that given to them. But the consumer just says, hey, I want a storage class name that gives me a lot of IO and mirrors my data 3 ways. Great. This is for the master nodes, which, as we mentioned earlier or at the top, it is important that those nodes come up as quickly as possible. They can self-heal. There is a data masters, but that takes time. And doing it this way, giving the block for block replication, literally turns your failure into seconds and however long it takes for the container to actually start up, then rather than startup plus data recovery on the application layer.
Okay.
And the other important thing is here is the data, the hot pool. Same thing. I'm saying, hey, I have a storage class that has a lot of IO attached to it, but it also has encryption flipped on. So all the volumes that I'm grabbing and consuming are going to be encrypted at rest. So the data that's getting stored on those nodes is going to be encrypted at rest. And on the other side, I have the warm, the warm pool. I'm going to give it still some resources, but I'm not going to give it the same amount of IO as my hot data, right? Hot data is the data that just came in, the data that I need to process and deal with and do reporting on right now. Warm data is data that like I can deal with later. So giving it less resources is important. And because I do not have access to external storage in our labs, what I'm doing is kind of simulating the same thing by giving the storage class of best effort, which means that, hey, if the cluster has resources to spare, I'll give it to you. If you don't, then you're kind of the last person to get any resources back. So again, if I had actual in the lab access to external storage, this would just be an external storage access point for my cold data. But here I'm just simulating the same thing using the best effort storage class.
Okay.
So what I'm going to do is I'm going to go back to the command line and I'm going to go ahead and deploy go ahead and deploy that cluster. And you'll see that it'll take it a second. It usually takes about a minute and a half, but I'm going to switch back to the GUI. You'll see as I'm going to switch to showing just the specific Elastic. You'll see things are coming up. Yeah, and you'll take it about from absolutely nothing to we have a Elasticsearch up and running. It takes about 2 minutes or so. And while it's coming up, I actually wanted to show what all of the different performance tiers that I was showing. If you remember that I used high, medium, and best effort, and here you can create your own tiers. We just give you a couple of default ones that you can delete and start from scratch. But you see that the high tier, whether it's mirrored or encrypted, it doesn't really matter. It says, hey, I need a minimum of 20,000 IOPS. I don't care what is happening on the cluster. I don't care where I am in the cluster. I need access to 20,000 IOPS and half a gig of network. You'll see that the max is left blank, but you can definitely floor and ceiling these different performance tiers. Same on the network side, you can floor and ceiling the network side. Medium only gets 5K, and then best effort, again, you see that it's got 0 IOPS. Essentially, that means that whatever is available, I'll give you, but that also means that whenever I need to, meet my guarantees for any of the other tiers, that this is the first to get kind of taken from.
So you're always going to get the best you can from each one of them from that minimum perspective.
Correct. I'm going to go back here to the storage classes, which again are 100% a Kubernetes object. Everybody that currently is running Kubernetes can go and view their storage classes and the different storage classes that they have access to. And if I were to create one, you can pick a different file system. We give you access to 3 different ones. You can pick the quality of service for that particular storage layer. Again, you can create your own different tiers as we just showed. You can pick the number of mirrors that you want of your data for that particular storage class. So maybe there's certain data that you don't need to be replicated on 3 different, have 3 different copies of the data. Maybe you want 2. And finally, you can flip on the encryption or not for that class. Excuse me. All right, so let's go back here. Now at this point, everything is up and running. What I did want to show was on the storage side. I'm going to go to persistent volume claims, which are, again, persistent volume claims are the standard Kubernetes object for data consumption, for storage consumption. So to the end user, all they say is, I want 100 gigs, I want 1 terabyte, I want, whatever they want as far as storage, and then we handle the rest. But you'll see that the different storage classes here are, let's see if I can make sure that this is a little more viewable. You can see that the hot nodes, there's 3 of them. They're using the high performance tier and they're encrypted. The warms are medium and encrypted. The masters are using high and they're mirrored 3 ways. And then the cold and some of the other nodes are just getting best effort. So at this point, everything should be up. Yeah, we are fully up. But the important thing is that Elastic by itself is great, and an Elastic expert can utilize Elastic without a UI and with just API access. But I am not that person, so what I'm going to do is I'm actually going to deploy Kibana as the front end of this Elastic cluster. Again, doing everything from scratch here. And what will happen now is you'll see there is a new Kibana container spinning up, and it has this IP. And this is important. I only kind of touched a little bit on this at the top, but with our network model, with our CNI, any container that spins up is given a live IP on your network. It's the equivalent of plugging a Cat6 cable right in the back of the container. You can plug this IP in your load balancer. You can plug it into a traffic shaper. You can plug it into a firewall. You can do everything that you normally can with a living, breathing IP on your network to these containers. So what I'm going to do is I'm going to go straight to that IP on the Kibana port to access Kibana.
And this again, is the private network that you talked about earlier, assuming.
Yeah, this is living on the private network. Let's see if it's okay. It's mostly up. I'll probably take it a couple of seconds to be fully ready. Okay, so it took about 1.5 minutes for Kibana to come up. So what we're going to do is I'm going to go straight into my browser and go on the Kibana port. Oh. There we go. I was almost afraid that the demo gods were against me.
Yeah, I think they're in our favor today.
Yeah. Okay. So by default, Elastic generates an admin password. It stores this in a Kubernetes secret, which we're going to utilize to extract the secure password. This is you can set this yourself, as in you do not have to let the operator generate one for you, but I like showing this as it is an important feature, right? Very often, what ends up happening is you know, utilizing the same password for a bunch of different clusters becomes unmanageable. Storing them in a standard Kubernetes object means that I can extract the password for each cluster, and that particular object is securely stored with that data within Kubernetes itself. I'm going to just load some of the sample data that Elastic comes with. But at this point, we have a fully functional Elasticsearch cluster that you can point your uh, endpoints to, whether it's through FileBeat, FluentD, uh, whatever your endpoints that you have, Kafka, now can start pushing data straight into this cluster. And I'm going to just pull up the dashboard for one of these just so you can see. It took seconds to import the data. This is just kind of a really good example of the great things that you can do with Elastic. We were talking about financials. This is the e-commerce data. You can now start seeing, hey, start clicking on things and experiencing. You're ringing.
Yeah, I'm impressed with the speed that that was deployed, and you've got data in there already.
All right. And what I'll do is I'll come into monitoring here, and I'm just gonna quickly turn this on to just show you at this point, again, as an end user, if you did not want to, you never have to see the Diamanti GUI. You just have to see and utilize what you're familiar with, which is Elasticsearch as an Elasticsearch consumer. Right? You can go, you see the full health of your cluster. You can go and dive, deep into what each node is doing, how much data is coming, how many shards are living. You can see that there's a bunch of shards that are living within the different pools, and you just have again just a normal interaction with your Elasticsearch cluster. You don't have to know anything new or uh, deal with again just things that maybe that you don't want to care to interact and deal with at the moment. You just want Elasticsearch that I can push data in and know that it is resilient and it's going to give me the ability to solve the problem that I'm trying to solve.
Yeah, because from the start, I know you had the storage classes already created on there, but other than that, you didn't use any of the Diamanti console to create anything. It was just kube control and the config YAML files.
Yeah, correct. I can't stress this enough. The CNCF certification is very, very important. Whether you use Diamanti or not, doesn't matter. Always look for that CNCF certification because it does truly mean that I can now take the YAML file that I've shown you and deploy it on OpenShift or deploy it to EKS, GKE. It doesn't matter. It will run. Obviously, the performance will be different based on how much money you want to spend in the public cloud. But the general structure and the way you would access it stays the same, which again, very, very important when you start coming into the hybrid cloud world.
So just talk a little bit about the latest release. So what we're getting with Spectra 3 is that hybrid cloud environment. So if a user wanted to deploy both in GKE and also on a cluster, they can use the same infrastructure and same command line to do that, but they can also then replicate data between the two environments.
Correct. Let me switch back to showing some slides here to just better illustrate this. So the Spectra 3.0 release is our next generation software release. It is slated for public consumption, actually, in I believe at this point, a week and a half, maybe 2 weeks.
So not long to
And
wait.
what we're, yeah, it is not long to wait. And what we're trying to solve with it is the hybrid cloud that everybody wants, but also give you the federated Kubernetes that you need in order to be able to do this. And the way we layer this is, again, there are some applications that don't make sense to run on-prem, right? Paying a couple of cents an hour in a public cloud for your Nginx or Apache front end makes sense. It's, call it hands off. But maybe running your Elastic in the public cloud where it's thousands of dollars an hour, that doesn't make sense. Uh, Even though there isn't a single pane of glass that you can currently hop to and view all those clusters and then go, man, the resources that I'm spending in the public cloud are not being utilized, but we should move this over to on-prem where this workload makes more sense, and it's literally a click of the button rather than how am I going to migrate my data, how am I going to migrate my workload, how am I going to deal with all of this. We just kind of give you the single pane of glass that everybody wants. And this is the just kind of the general overview of our journey to get to Spectra 3.0, if you will. When the company started, we saw the kind of this bottom layer, right? The hey, look, there isn't a good Kubernetes infrastructure out there. You know, you can buy a bunch of servers from a vendor and do Kubernetes by yourself and then worry about solving the storage problems and the networking problems and the how do I upgrade problems and everything else. So that's what our D20 platform solved. But then we realized that, look, our features are really great, but users um, do truly want that flexibility to go to Azure, to go to Google, to go to Amazon and consume their services because their services solve a certain problem that, uh, well, it doesn't really make sense to kind of reinvent the wheel to solve with an on-prem solution. So what we decided is like, okay, why not again marry all those services together under a single banner and give you a seamless experience across all the different platforms. So that's where our next iteration of the company is kind of coming into the cluster management and application management layers. And from the get-go, we're looking to support vanilla Kubernetes and OpenShift, which means that you can bring in your existing clusters, you can bring in Azure clusters, you can bring in Google clusters, and have a seamless runtime, update and upgrade process, and obviously RBAC that is universal across all those different platforms. And this is kind of what it looks like on from a 10,000 meter view, right? We believe that as a company, most companies kind of would love to be able to um, log into a single instance that is able to give them a view of all their business units and what the utilization of those business units of the company's resources are. Maybe some business units say the DevOps team needs access to 2, 3, 4, 5, 10 different Kubernetes clusters. and maybe they want to be able to kind of promote workloads between those different clusters, and you want those different clusters to be um, different geographic locations, so on and so forth. But as a kind of as a company, I want to be able to log in, view all this information, and see where my hotspots are. As a business unit, I want the same thing. Obviously, my scope is much more narrow. I'm only looking at the resources that the company has given me access to. But as a business unit and as a business unit leader, I want to be able to say, okay, hey, look, on these projects, we're utilizing a fraction of what we have. Let's clean this up. Let's stop spending money where we don't have to stop spending money. Let's shift workloads, and all of this again being done seamlessly rather than having to figure out, okay, how am I going to move my data? How am I going to stand up the equivalent in Azure that was sitting in Google? And that's the kind of the problem and the problem statement that we're solving here.
I think one of the key things is giving people that flexibility, isn't it?
Yeah, for sure, for sure. And this is all not coming from, we didn't just wake up one day and go, you know what, this is what's needed. All of this is coming from our existing clients, and from prospects, and from just reading the industry. And everybody wants that utopia, if you will, and nobody has been able to deliver. And we believe that based on kind of the roots that we have within the ecosystem now, gives us a nice leg up into solving that problem for for the industry.
So when could we maybe do another session with you and actually show the the Spectra 3 capabilities and look at workloads across multiple platforms? Is that something we could do in a couple of weeks' time?
Yeah, it'll probably be 2 to 3 weeks, but we can definitely do another session, and do a similar thing
Okay.
with our 3.0.
Right, we come up to an hour for this session. We don't normally do, but we needed to cover quite a lot today to actually show that end to end.
Yeah.
One, the theoretical, what was going to be done and how it was going to be done. Also, the savings and the amount of infrastructure and increase in performance. But then finally, to demonstrate how easy it is to do it again without utilizing any other tools than a traditional, container administrator would have or developer. So I think we've proved all of those things. So thank you very much for your time today, Boris. I think it's been really useful, and hopefully we can get you back, like I say, soon to cover off a little piece around Spectre 3 when Spectre 3 is available.
Yeah, no, thank you for having me, and hopefully we'll chat in a few weeks.
That sounds good. Thank you very much for your time.
Thank you.
Bye.